A long-awaited human mission to the Red Planet is still a number of years away, with NASA planning their first manned voyage in the 2030s. But at more than 55 million kilometers away, astronauts face at least half a year of space travel just to get to Mars, not to mention the return journey. Of the multitude of obstacles to overcome, the health of the astronauts during such a long period in space is of chief concern. Scientists in Germany are using advanced imaging technology in a bid to understand one unusual phenomenon: why astronauts' skin gets thinner while in space. Led by Professor Karsten Koenig from the Department of Biophotonics and Laser Technology at Saarland University, researchers have used high-resolution skin imaging tomography to look into the skin cells of several astronauts before and after a trip into space. The developers of the laser technology say the spatial resolution is 1,000 times higher than that of ultrasonic devices, unmatched by any other product. It also has the potential, Koenig says, to revolutionize diagnoses in hospitals. We use femtosecond laser pulses. We scan the skin and we get signals from the skin, particularly fluorescence, as well as another signal called second harmonic generation. So with these two signals we can build up images and get a precise look into the skin with a high resolution. The resolution is a factor of 1,000 times better than ultrasound. So now you get the information without taking biopsies. Normally you slice them, you stain them, and then a pathologist would look through these sections. Now you can get this information in seconds, labor-free and with this fantastic resolution, said Koenig, adding that applications include in vivo histology for early cancer diagnosis and determining effects of skin aging. Koenig, who is also CEO of German company TenLab, with facilities in Jena and Saarbrücken, was asked by the European Space Agency ESA to use their femtosecond laser technology for their SkinBee project, which the Space Agency says is aimed at understanding skin aging mechanisms which are slow on Earth, therefore nearly impossible to study efficiently but very much accelerated in weightlessness. NASA and ESA, the European Space Agency, came to us and asked, is it possible to also look in the skins of astronauts? Because we want to know if there's any aging process going on or what kind of modifications happened to astronauts as they were for 6 months out in space. Because many astronauts complain about skin problems, said Koenig. So far, Koenig and his team of researchers have scanned 3 astronauts before and after a trip into space, the Italians Luca Parmigiano and Samantha Cristoforetti, and Germany's Alexander Gerst. Cristoforetti, of the ESA, was scanned prior to her trip to the International Space Station ISS in November 2014. When Cristoforetti landed back on Earth on June 11 this year, her 199-day mission meant she became the new record holder for the single longest space flight by a woman, eclipsing NASA's Sunita Williams' 195-day flight in 2006 to 2007. Cristoforetti's skin cells were subsequently re-scanned by Koenig, who explained how on the ISS skin physiology is different, leading to some surprising results. So far we've got interesting results from 3 astronauts. It seems that there is a strong production of collagen, so suddenly these astronauts have more collagen. It means there is some sort of anti-aging effect, at least in the dermis, the lower part of the skin. And we found that the epidermis, in particular the part of the living cells, that this epidermis is shrinking, so the skin gets thinner, Koenig said. So far we have no explanation yet, and we are waiting for the other astronauts to figure out what's going on and maybe to try to figure out how we can protect, how we can help so that this epidermis is not shrinking, he added. NASA is developing capabilities to send astronauts to an asteroid in the 2020s aboard their Orion spacecraft, giving them the chance to test new systems and capabilities beyond low Earth orbit. This is to prepare for future human missions to Mars, the U.S. Space Agency said. In the meantime, Koenig and his team will continue their research into what causes the thinning of astronauts' skin, and more crucially, how it can be prevented. We've seen the epidermis get thinner by nearly 20%. And so far we have no explanation. But this happened within 6 months. The question is, if you go to Mars they need 1 or 2 years and we don't know yet. For sure it's not so good if the epidermis gets thinner and thinner, Koenig said.